So today, like I said, we'll cover that last topic for the quiz, or review on the last topic here for the quiz, which is the rational zeros test. All right. So having kind of gone through a bunch of different tools to factor polynomials, again, GCF, factor by grouping, substitution, using long division and synthetic division were the two kind of like last tools that we learned, right? And those are helpful, but the problem with longer synthetic division is you kind of like need to know what you're dividing by, or at least be a really good guesser, right? Because when we factor using those other methods, GCF, substitution, factor by grouping, we don't need to know what we're dividing by. We just kind of like do this factoring thing, and the factors kind of show up. But with long and synthetic division, you kind of need to know, oh, divide by this, kind of thing. And of course, if you're not told that, well, we're just left to guess. And guessing, again, we're not maybe going to be very good guessers, especially if there's an infinite number of possibilities. So we're going to try and limit the list of those choices, basically, using the rational zero test. Okay. So let's take a look at that. Okay. So again, it gives us a list of possible, so that's key, right? These are just possible rational zeros for a given polynomial. Okay. Notice it doesn't say it gives us the rational zeros, right? It gives us a list of possible ones. Now, it is an exhaustive list. That means there won't be any rational zeros that are not on this list, okay? So there won't be any surprise rational zeros, okay? But this list can be kind of long, right? And does a polynomial have to have rational zeros? It does not. It can be made completely up of imaginary zeros, in which case, this also still fails. So we still don't have a completely, foolproof, I guess, method of, being able to factor any polynomial we come across. If our polynomial has a bunch of imaginary roots, this won't work for us. Okay, and in fact, but we're okay with that for some reason. We just stop here. So anyway, let's take a look here. So we'll start by looking at a polynomial, x to the third plus 2x squared minus 4x minus 8. Okay. Now, given what we already know, right, all the strategies we already have at our disposal here, is it going to be necessary for us to do anything fancy here? Like, do we need to use anything fancy beyond what we already know to factor this? Like, are we going to need the rational zero test here at all? Yeah, it factors by grouping, exactly right. So like there's not even a need here for this rational zero test. But we're going to use it with something that we know factors, and then kind of see where the zeros show up and stuff like that. Okay? See where we're right. All right, so we're going to just ask the question though, what are the possible, because again, that's what the rational zero test gives us, just possible rational zeros for, and then that polynomial right there. Okay. Now I believe this is something you guys have seen before, so do you remember anything about it? What we're supposed to use from the polynomial here to help us find the zeros? Yeah, Jeff, you have an idea?
I remember that all the ones that are not rational, are they imaginary zeros?
Well, that's true. That's true. But I'm saying for the rational zero test. So but that's okay here. I'll just show you here. So what we do is we identify two important numbers here in our polynomial. We identify the constant term, okay, and we call that, or we kind of label that as being p. All right, and then we also identify our lead coefficient here, which in this case would be a 1, right? And we identify that as q. So we'll just put like a little dotted line 1 there, I guess, or something. I'll just put a whole 1 in there. Why hide it, right? Okay. So, having identified those numbers, p equals -8, Q equals 1. But Mr. Witt, P comes first alphabetically, but it's at the end, and Q comes next. But, anyway. I don't know why they chose to do it that way, but they did. Okay, so P is there, -8, and Q is 1. All right. The possible zeros, then, the possible zeros of this polynomial, okay, will be in the form factors of P divided by factors of Q. Okay, so if something, there you go. If something is going to be a zero, a rational zero of this polynomial, its form must be a factor of P divided by a factor of Q. Okay, where again P is the constant for the polynomial. Pens are dying. Q would be then the lead coefficient. Oi. All right, let's try this one again. Cool. Pens die left and right. Let's go to, do I have a black one? Let's see over here. Yeah. All right. So let's identify those here. So what would be the factors of P in this situation then? Okay, what divides P evenly here? Okay, Jeff, go ahead.
So for -8,
Mm-hmm.
it's 4, -4, 2, -2, 8, and -8.
And then and one more. You got 2. You got, yeah, exactly right. Yeah, don't forget the other easy one there besides
1
the 8.
and
1, 2, 4, 8. Plus or minus 1, 2,
and
4, 8.
-1.
Right, 1 and -1. Yep.
And then the other one, for 1, the only factors are 1 and -1.
And then right for Q, okay, the factors are yes, +1 or -1 there. Okay, so that's right. So yeah, 1, 2, 4, and 8 all divide -8 evenly, right? So do +1 and -1. And yes, we need to account for those positive and negative signs. Okay. So then all the possible zeros, which is what we're being asked to come up with here, not to find the rational, not to find the actual zeros. We just want to come up with the possible rational zeros. Okay, they're going to be in the form P over Q. So it'll be +or-1 over +or-1, which is, well, +or-1, right? And then +or-2 over +or-1, which is +or-2. 4 over 1, so 4, and then 8 over 1, so 8. Okay. So 8 possibilities there, right? 8 possibilities to potentially check or to look through and stuff like that. All right. So let's actually find the rational zeros. Okay. Well, like I said, or like Ro said earlier, right? This thing, or was it Ro? I forget. Who said it was going to be? Who said this factor by grouping? Someone did. My apologies, I forgot already. Okay. It was Ethan. All right, factor by grouping. Let's see, right? So let's see what the actual zeros are here. So we can factor out an x squared. We're left with x plus 2. Factor out a -4 here. We're left with x plus 2. Hence we have x plus 2 times x squared minus 4, which is then x plus 2, x minus 2, x plus 2. Okay? So we can see we really have 2 zeros. X equals 2 and x equals -2 are our 2 zeros there. Okay, if we set it equal to 0, I guess I should have done that up here. And they're in our list, right? There they are, +or -2. So you see we're not going to necessarily use all those zeros, right? These are possible zeros. It's a list of possible choices here. All right? But there they are. All right, questions on any of that? Easy peasy. You guys remember this from Algebra 2? Yes? So, all right. I'll try not to belabor this too much then. Let's see. All right, well, let's maybe have you guys try one here then. All right, so let's see. Well, we'll do one more here together, and then I'll have you guys try one on your own. We'll do one more here together, and then I'll let you try one on your own. Let's do this one. Let's make it more interesting, though. So let's find the rational roots of 6x to the third plus 17x squared minus 26x plus 8. Okay. So, can we solve this one using any of our prior strategies? Is there a GCF? No. We could factor by grouping, but it's not going to be helpful because we're not going to get like matching factors. We could factor an x squared out of here, leaving us with 6x plus 17. But if we factor a 2 out of here, we'll have like 13x plus 4, or negative 2 would be positive 13x minus 4, I guess. But still, again, won't match up. Excuse me. So let's go through this using the rational roots and stuff like that. So 8 is our p, right? 6 is our q. All right, so we're going to have to use that. So again, the factors will be in the form p over q. So it'll be plus or minus 1, 2, 4, and 8 for the factors of p, and for the factors of q, 1, 2, 3, and 6. Okay. And just for fun here, let's list out the possible zeros, or I'm going to list out the possible zeros. If you just want to, watch and marvel at it, that's fine too. I understand. Okay, but I'm going to list out the possible zeros here. Okay, just so you can see. So the difference here about this problem, right, is that we had multiple factors for p, just like in the last problem, but in this one, now we have multiple factors for q as well, and so we have multiple combinations. So in other words, we can do 1 over 1, 2 over 1, 4 over 1, 8 over 1, but then we can also do 1 over 2, 2 over 2, 4 over 2, 8 over 2, and then 1 over 3, 2 over 3, 4 over 3, 8 over 3, and then 1 over 6, 2 over 6, 4 over 6, 8 over 6. It's a lot, right? So let's go ahead. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, right? That's the 1 over 1, 2 over 1, 4 over 1, 8 over 1. Then I'll do the 1 over the 2, and I'll go over the 2, so 1 over 2, 2 over 2, so on and so forth. So 1 over 2, that'd be plus or minus 1/2. Plus or minus 2 over 2, do I need to write that one down? No, why not? Yeah, we already got plus or minus 1, right? 2 over 2 simplifies to 1 over 1, or 1. So same thing with 4 over 2, right? That's 2, we've got that. And same thing with 8 over 2, we've got that, that's 4. All right, so let's go to the next one then. Do I have to write down plus or minus 1 over 3? Yes, we don't have that one, right? So plus or minus 1 over 3. But then 2 over 3, do I have to write that one down? Trick question, I do, yes. Or trick voice. So yeah, and then plus or minus 4 thirds, plus or minus 8 thirds, all those thirds ones we have to write down. They don't simplify to anything that we had before. But then let's see here, 1 over 6, got to put that one down. But then 2 over 6, do we have to put that one down? No, because it's not, it simplifies to 1/3. 4, 6 simplifies to 2/3, which again we have. And then 8, 6 simplifies to 4/3. Actually, I don't even need that there. Okay, so there's our comprehensive list of all the possible rational roots there. Okay, quite a few. All right, now, again, we're not asked to find the possible ones here. We want to find the possible ones. We want the actual zeros here, which means at this point, now that we have our list of possible zeros, we have to guess, right? Like we have to kind of just pick a number and check it, either by doing long division or synthetic division. I suggest synthetic division, right? And that can be kind of awful because there's so many options here, right? There's 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. There's 20 options. So if you're a bad guesser, you could go through a lot of these zeros before you find one, okay? I will tell you guys this, right? I try not to be very cruel when it comes to these problems, right? Okay? You should, if you if you list your zeros out similarly to how I did, where I list, all the the over 1 kind of things, you should be able to find a 0 within these first couple, numbers here. Okay, I try to make sure that happens, or the way the problems that are written, the author tried to make sure that happens, because otherwise it's a lot of guessing. I know there's other tricks too with like how many times a sign changes and stuff like that. I'm not going to have you guys worry about learning any of that stuff, okay? Just because I feel like we get the gist of the rational zeros with this, and yeah, I'm okay with that. So anyway, let's guess here, and I'm going to guess 1, okay, just to start out and hope that it works. Okay, so that means then 6, 17, negative 26, and 8. Okay, so if I drop down the 6, I get 6 times 1 is 6, so that's going to be 23, 23, and negative 26 and 23 is negative 3. Negative 3 times 1 is negative 3, and that gives us, oh man, I chose poorly. All right. That's not very good. All right. So 1 is not a 0. Let me guess again. 1/2. Let's try 1/2. Okay. Try 1/2. Let's see here. Drop down that 6. 6 times 1/2 is 3. 17 and 3 is 20. Times 1/2 is 10. Negative 16. Negative 16 times 1/2 is negative 8. Oh. Phew. Not bad. Okay. So we found a 0. X equals 1/2 is a 0. Okay. That's one of our zeros. So at this point, if we want to find any more zeros, should we keep guessing? I already checked 1 and 1/2, so I could try negative 1, I could try negative 1/2, I could try plus or minus 2, 4, 8, 1/3, 2/3, 4/3, 8/3, 1/6. Do I need to keep guessing here? Why not? It's a quadratic now. That's right. We started with a cubic. It's down to a quadratic. So let's just see if we can factor this the old-fashioned way, since it's now just a quadratic. Bless you, bless you. All right? Yeah, right. Sneeze jinx. All right. So we'll factor out a 2 here, GCF. Okay, and let's see. We know we're going to need a 3x and an x there. And let me see. And again, you can use the AC method if you want to there, however you want to do that. Thinking 4 and 2 maybe. Let's see. So plus 4 minus 2 there. Okay, so yeah, 3x minus 2, x plus 4. It works. Very good. And so then, yeah, we get the 3x minus 2 equals 0, the x plus 4 equals 0, and so we get x equals 2/3 and x equals negative 4. Okay. And do we need to go looking for any more zeros? No, it's cubic, right? So the most zeros we're going to have are 3. And we've got 1, 2, 3. There they are. And of course, they are in our list, right? 2/3 is also in our list right there. And negative 4 is also in our list right there. Okay, so those are our zeros. Okay. Questions on any of that? Ready to try one on your own now? All right. Try this one here. Okay. Find all the rational roots of x to the third minus 6x squared plus 11x minus 6. So I was kind to you there. Gave you a 1 for a lead coefficient. Okay. Please watch your arithmetic when it comes to your synthetic division and stuff like that. I've had students that have taken like, I don't know, 10, 15 minutes longer on their quiz tomorrow because they were messing up their arithmetic and they couldn't find a 0. They're like, Mr. Wade, are you sure this factors? I'm like, yes, it does, but watch your arithmetic, please.
Plus how many x? Is it 1?
Plus 11x. 11. Those are.
I thought that was just my poor vision making it look double.
Not doubling a lot. No. Nope. Your vision's not as bad as you thought, I guess. factor would then be potentially like an x minus 1 or something like that. 0 is the number that you used, yeah. Everyone get a chance to fill out the score on the sheet here?
I found a 0, but it doesn't help me. It doesn't turn anything quadratic because it's 1.
Should turn into a quadratic. So what you do, use synthetic division on it to then reduce it by a degree. Yes. Yes, use synthetic division. So what you did was not wrong. It's a helpful strategy, but it'll be more helpful to use synthetic division to reduce it. 1 minus 0. Give me like 30 more seconds here. Well, never mind. I already showed it. Forget to freeze things. Never mind. Once you finish up, there it is on the board.
Mr. Wynn?
Yep.
I'm confused because I thought you put the opposite in the little box thingy.
Correct. The opposite of the factor. So what this means is like for example here, right, x minus 2 is the factor of that quadratic. But then what's the 0? 2. Okay? So if you were going to try and synthetically divide here by x minus 2, it would be a 2 that you put in the box. So it's the 0 that goes in the box. The 0 does. So if 1 works, 1 is a 0. It makes the polynomial 0. Okay, but the factor will be the opposite sign. Okay, so that helps some there, yeah. All right. So there's the answer to that one. I've got one more here that I want you guys to try though before we say done. Right. So one more here, and it's going to be similar, but I'm going to have you, instead of saying finding the rational roots, I want you to find the real roots of, and I'll give you another one here, x to the third plus 7x squared minus 38x plus 24. Alright, so I want you to find the real roots of that. Now, I will give you a hint here, I guess. I'll give you a hint. You should, so once you've done your rational roots test, you should have a root that is less than or equal to 3. Okay? So I know your possible roots here are all the factors of 24, right? So potentially you can check plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4. But you should be able to find a root within plus or minus 1, plus or minus 2, plus or minus 3. Okay, I'll give you that.
Is
that much of a hint.
division wrong?
What's that? What did you guess? Oh, is this for, I see what you're saying. This is for the first one we did, right? Let me see. 1 negative 6, 11 negative 6. So, drop the 1 down. So 1, you did kind of do that, I guess. Okay. So 1 plus 1, 1 negative 6. So that'd be negative 5. Right? Because negative 6 plus 1 is negative 5.
Oh.
And that's going to affect the rest of it then, too.
But the rest of it's right?
Well, but now you have to go back and fix everything else because when you had before, you did positive 5 times 1, but it'd be negative 5 times 1, so that'd be a negative 5. And then 11 plus negative 5 would be a 6 there, right? And then 6 times 1 is 6, put a 6 there.
So it's this times that, not this times that.
It is this times that goes here. Or this times that goes there, like that. Okay? Yeah, so you add. So if you start by doing the 1, bring it down, 1 times 1.
So that's 1 times 6 is,
So it'd be 6 times 1 goes there. So it'd be 6 right here. 6 right here. 6 right. And then add them up, and that gives you what your 0 is there. 0, right. So again, there are many, the list of rational roots for this one are plus or minus 1, 2, 3, 4, 6, 8, 12, 24. There should be a root. There should be a rational 0. One of your zeros should be plus or minus 1, plus or minus 2, plus or minus 3. Okay? And then that'll help you get down to a quadratic and you go from there. Okay. is factoring the only way we have to find zeros or roots of a quadratic.
Are you telling me to do the quadratic?
I'm not telling you to do anything. I'm asking you a question. What's the answer to the question? You can try that. Yeah, that could be something. Yeah. So what did you decide upon?
Yeah.
If it doesn't factor, and you want to find the zeros. Did you get 1, 2, 3?
What?
1, 2, 3?
I got -1, 0, and 1.
I think you're missing, oh, so when you do your, there's a 1 here, 1 plus the 0, when you drop that 1 down, so it's 1 x squared minus 5x plus 6.
What?
There was a 1, -6, 11, and -6 there, so the 1 drops down, yeah, so make sure you always drop down that lead coefficient there. Okay, but now you can factor it. You don't have to use quadratic formula for what you did there. In fact, you didn't use quadratic formula here either. You can just factor an x out. Set both things equal to 0. Both factors equal to 0 there too. I know. 60. Well, you can, but not on the first try maybe, but you'll have to keep practicing at it, right?
Yeah.
So that's just it. So we're gonna
Can't
have
do
some.
the next problem though,
Why can't you do the next one?
because that one's even harder.
That doesn't mean you can't do it still. Same principles apply. Same principles apply here. And I told you that
Can I just work on the homework? Usually the first couple questions on the homework are easier.
normally yes, but if you don't want to practice the stuff I've given you here, you might not be as ready for the.
I know, but I gotta start.
Yeah. That's true. That's true. Okay. So 3, hopefully you got 3 to work there. Yeah? 3 works. Okay, and so then we can simplify the quadratic formula here, because that's unfortunately what we're left with, right? Is that, what's it going to be? 2, no, root 33 there. Nothing like that. Okay. Oh, wait, negative 10 over 2 is not negative 5 has. Yeah, that's my bad there. There we go. Okay, so those are your other two zeros. So x equals 3 is a 0, and then x equals plus or minus, or negative 5 plus or minus root 33 there. Okay, sorry, those are two answers. Now, a couple things I want to talk about here real quick, right? So we didn't worry about the quadratic formula in the previous problems because we were only asked to find rational zeros. Okay, so rational zeros, right, would exclude anything that has a square root in it that's not, well, it doesn't imply nicely, right? Because those are irrational, right? So square root of 33, right, if you're given this problem, irrational. So we wouldn't include that if we're just looking for the rational roots. If we're looking for the real roots, that's where you got to bring in this quadratic formula potentially. Okay, it's not always the case, but this, in this case. So, but same principle still apply. Get your list of possible zeros. Figure out which one, figure out one that works, or keep figuring out ones that work until you get down to a quadratic, and then factor the quadratic by hand, or use the quadratic formula if you need to. Okay. One other thing I want to mention here: once we got this polynomial down to the answer right here, the x squared plus 10x minus 8, okay, does this polynomial, this quadratic, does it have the same list of zeros as this one does? Are the possible zeros for this the same as the possible zeros for this? Not exactly, right? This one, the p is 24. So this includes like plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, so on and so forth. But when the when the p changes here to 8, you have a new list of zeros that you can use, right? You can eliminate some of those other zeros. So if you had to guess and check on this one, right, you wouldn't need to use the plus or minus 24 because that doesn't divide 8, right? Or 8's not a factor, or 24 is not a factor of 8. Sorry. Okay, 6 also, you wouldn't have to use that one and stuff. So anytime you use a new zero, you can, if you want, reevaluate your list of zeros, right, from that solution there, from the reduced kind of polynomial, and you can reevaluate your zero list to see, if you get any more, or sorry, if you can get a lower list, a smaller list to choose from and stuff. Okay, so sorry, Jen, a question?
Yeah, I don't remember. Oh, so is the answer just 3?
The answer is 3 and these two, because the directions are to find the real roots. So real roots would include, square roots that don't simplify and stuff like that. Okay, yeah, Molly?
Wouldn't it be 2 root 33? If you simplify 132, it's 4 root.
Yes, but then that also gets divided by 2 as well. Since both the negative 10 and the plus or minus, that square root, both are being divided by 2, then it'd be just both get divided by 2. Don't understand? Okay, so let's see here. So you're okay with to this point right here, negative 10 plus or minus root 132 over 2?
Yeah, and then I simplified it.
Okay.
2 got 4 root 33.
Yeah, exactly. Oh, it's 4 root. Okay, it's 4 root 33, or it should be 4 times 33 is root 132.
Yeah, that's what I meant.
Okay, so I'll show you. I'll do it on the board here. So so we have this. 132. Okay, and so that's negative 10 plus or minus. You said you had 4 root 33, but it becomes 2 root 33 when you pull the 4 out of the square root, right?
Oh, okay, never mind.
And then you see what I'm saying? Yeah, there you go. Okay, and then divide this by 2. And there you go. Get the negative 5, you get the root 33. Okay, woo! So there we go. That was fun. All right. So your homework is already posted to Google Classroom, so you can get started on that right there. All right, get some practice in and stuff like that. All right. If you're feeling good on this stuff, feeling good on the other quiz topics, feel free to work on something else for another class, or if you've got, again, you work on that PSAT stuff. It's now October, so the PSAT is coming up in a week and a couple days, right? A week from Wednesday is the PSAT.